All right, today's lesson is about analytical geometry. So first and foremost, we're going to be defining analytical geometry and talking about what the lesson is about. So analytical geometry is the study of what? Geometry using the Cartesian plane, meaning to say that we are studying geometry, but we are using the Cartesian plane. And today's lesson, this particular video, it's about calculating the distance between 2 points. What are points? If you look at this diagram, we've got this point, which is point A, and we've got point B. We want to know how long line AB is. So in order for us to know how long line AB is, we're going to be using what? We're going to be using what we call coordinates, right? And when we use these coordinates, we now use, we use them on what we call the distance formula. So we've got different variations of the distance formula. The first variation which we have, which is here, is AB is equals to square root of open bracket xb minus xa close bracket squared plus yb minus ya close bracket squared. What does that mean? If we come to this example that we have here of line AB, we are simply saying that we're going to start by taking what? The coordinate, the x coordinate of this point, what? Point B, right? So we come and we say line AB here is equal to square root, right? Then the coordinate for point, the x coordinate at point B is 3. So we now say open bracket 3 minus, right? We are told XA. So we are looking at the coordinate. The x coordinate at point A is -2. So we open the bracket, we say -2. We close the bracket, we close the bracket. We then say squared. That's what it means, right? Then we say plus here, we open the bracket. We are now told YB minus YA, right? So YB minus YA, we are now coming to this coordinate of point B, which is 2. We say 2 minus. If we come to the y coordinate of point A, it's -2. So we open the bracket, we say -2. We close the bracket, we close the bracket, we then say squared. Then we close the square root, the hood of the square root. Now from there we proceed and we say AB is equal to, our board mass tells us that we must start with there are brackets. So in this particular instance, we've got here where we are having these signs which must multiply. So I open the bracket, I rewrite 3, I say negative times negative, which gives me a positive 2. Close bracket squared plus negative and negative, it's another positive. So we've got 2 plus 2 close bracket squared. We close the hood of the square root. Now, I know that 3 plus 2 is equals to 5. And then 5 squared is equal to what? It is equals to 25. So now I say AB is equal to 25 plus 2 plus 2 is equal to 4. 4 squared is equal to 16. So I say 16 here. Then 25 plus 16 gives me 41. So now I've got AB, which is equals to square root of 41. When I look at this number 41, 41 is not, number 41 is not a perfect square. So here the square root which I have is a square root of a non-perfect square. So I can conclude that therefore AB is equals to square root of 41, right? So that's how we use the distance formula, right? But like I said, there are other variations, right? So we'll be using some of the variations on the other questions, like this one and that one. But let me just explain here where it's written AB is equals to square root of x2 minus x1. Here they are now using numbers, and there we had what? Letters. So how do you use these numbers? So let's come here and we say AB, right, is equal to, we're going to be using these coordinates, coordinate A and B. Now we say square root of open bracket. Now, if I come to the alphabetical order, I've got point A and point B, right? The latter, meaning to say that the last amongst these two is what? Is point B. So this point B now, that's what we call number 2. And this one, the former, which is the first, we call it number 1. So when they say x2 minus x1, they're simply saying that your x coordinate on number 2, which is 3. So we say 3 minus the x at point 1. Our x is -2. So we say open bracket -2, close bracket squared, plus here y2, this is the y at point at 2, which is now 2 minus. Our y at point 1 is negative 2. So we say negative 2, close bracket, squared, like that. Now, if you check here, the first here, when we were saying xb minus xa, we had 3, there is 3. Minus, negative 2 inside the brackets, negative 2 inside the brackets. So this part on the top and that part at the bottom, they are identical. This part, there is 2, minus, negative 2 inside the brackets, negative 2, squared. So if you continue with these calculations, everything else is exactly identical. That's how you use this particular formula. So it's the same formula, we are just using different variables. Okay, now we've got another question. We're still talking about what? We're still talking about the distance formula. Now, let's go and see this question and what it entails. Now, in this particular question, we are told that, as you can see, we've got triangle ABC. What does it say? It says that in the diagram, the vertices of triangle ABC, where these two lines, where this CA and BA are meeting, this is what is called a vertex. You need two sides in order for something to be a vertex. This C is a vertex because AC and BC, they are meeting here, and this point B is a vertex because line AB and line CB, they are meeting there. That's what is meant by vertices. You did this work in primary, grade 6 to be exact. Now, in the diagram, the vertices of triangle ABC are, at point A, we are given the coordinates, they are the coordinates. Point B, they are the coordinates, and point C, they are the coordinates. Now, what is the question asking? Now, they say that, show that triangle ABC is an isosceles triangle. So, we must show that this triangle we have here, it is an isosceles. What do we know about an isosceles? We know that an isosceles has got two equal sides and two equal angles. But here we're not going to be exploring any angles, which means that we've been given the distance formula. So we must find out that how long is line AB, how long is line AC, how long is line CB. And then when we are done, will we have any of these two sides which are equal? If we find two sides which are going to be equal, then it tells us to say that this triangle ABC is a isosceles. If all three sides are not equal, then it may tell us that it's a scaling. But if three sides are equal, then it's an equilateral. So that's what we determine, and we're going to be using the distance formula. So let's start. Now I'm going to start with what? Line AB. So I come here and I say AB is equal to, open bracket. I'm still using the formula that I showed you on the other section of the board. So I come here, this is my XB, which is number 5. So I open the bracket, I say 5 minus, my X at point A is 2, so 5 minus 2, close the bracket, squared, plus, open bracket, my Y at point B is what? Is 7. So I say 7 minus, my Y at point A is 3, minus 3, close bracket, squared. Then from there we say AB is equal to, now when I say 5 minus 2, it gives me 3. So now I've got open bracket 3 squared plus 7 minus 3 is equal to 4. So I've got 4 squared. AB is equal to, when I say 3 squared, I get 9. So I say here I've got 9 plus 4 squared is equals to 16. Now, when I say 16 plus 9, it gives me 25. And what is the square root of 25? The square root of 25 is 5. So I conclude that, therefore, AB is equal to 5 units. We are not told about centimeters or meters. So if we're not told that, we then call them units in analytical geometry. So we mark here that we have calculated the distance of line AB. Now, let's calculate the distance of line AC. Now we say that AC, right? Now, remember, I said to you that we've got another variation, which is AB squared is equals to, open bracket, XB minus XA squared plus this one. And here there is no square root. So in order for us to use this formula and for you to know this formula, that's what we're going to use. So here we are now going to use what? we're going to use AC squared. What is our AC squared? We do not know the distance, so we are looking for line AC. We say AC squared is equal to, then we open the bracket. Now our point C is what? 6. So our x at point C is -2. So we say -2 minus our x at A is 2. Then we say squared plus, open bracket. Our y at point C is 6. So we say 6 minus our y at point A is 3 minus 3 squared. AC squared is equal to -2. -2 gives us what? -4. So we've got -4 squared plus 6 minus 3 is equal to what? It is equals to 3. So we've got 3 squared. Now, we say AC squared is equal to -4 squared, and it's inside the bracket, it gives us 16 plus 3 squared gives us 9. And 16 plus 9 is equal to what? 25. But remember, this number is squared. So when we want to remove this square, we use a square root. So now we use square root there, and we use a square root there, and then we say, therefore, AC is equal to what? Square root of 25 is 5. So we've got 5 units. Now observe, we've got 5 units there, and we've got 5 units here. So two sides are equal. But we can't conclude without calculating line CB, because what if line CB is equals to 5 as well? That would be an equilateral. So let's calculate line BC or CB. So we say BC is equal to, our point X at C is -2. So we say square root of, open bracket, -2 minus our point B is 5, close bracket, squared, plus our y there is 6 at point C. So we say 6 minus our y there is 7. So minus 7, close bracket, squared. Then we close the hood of the square root. We say BC is equal to -2, -5, it gives us -7. So we say square root, open bracket, -7, close bracket, squared, plus 6 minus 7 is equals to -1. So we've got -1 here, squared. And BC is equal to square root of -7 squared is equal to 49, plus -1 squared is equal to 1. Square root of 49 plus 1 is equals to 50. So we've got square root of 50 here. Then we conclude, therefore, BC is equals to square root of 50. Why am I doing this? This is not a perfect square. 50 is not a perfect square, and it's different from what we got, 25, square root of 25 and square root of 25, which was 5 units, perfect squares. So we can conclude that, therefore, triangle ABC is an isosceles because we've got 2 equal sides. So I hope it makes sense. Now, they say, B, calculate the perimeter of triangle ABC correct to 1 decimal place. Now, this is easy. Why are we saying that this is easy? Because what we do then, this is what we do. We are now saying side AB plus line AC plus line BC is equal to the perimeter of triangle ABC. On line AB, what was my distance? My distance at line AB, it was 5 units. So I say 5 plus, at line AC, it was 5 units. Plus, I've got square root of what? Square root of 50. Then here, I go and I take the calculator. I place it into the calculator. So now I say 5 plus 5 plus square root of 50, which is equal to 10, 5 square root of. But that's not what we want. They want it to 1 decimal place. So I press my S to D. Then it gives me 17,07. When they say to 1 decimal place, this number after the comma right? But before I say 0, I must look at the second decimal number. If it's above 4, then we add 1. If it's less than 4, then it remains as is. So 7 is above 4, which means we add 1. So it becomes 17,1 units. So our answer is 17,1 units. And as you can see, what we did in this lesson, I gave you the formula for the distance formula, and then this is what we call application of the distance formula, meaning to say that we are using the distance formula, right? So if you found this lesson to be helpful, please do consider to subscribe, share with those who you go to school with, like and comment. If you've got any suggestions or there's something that you'd like me to teach, just comment. Thank you.